All right, 2.5, limits, infinite limits. So here we go. Let's pull up the notes and get started. All right, so infinite limits are, we're going to talk about limits at infinity next time. The infinite limits are limits technically that does not exist. But instead of saying does not exist, you can describe what happens at that value. If it doesn't exist, but it's approaching infinity, you can say it's going to positive infinity or negative infinity, or maybe it's going to positive infinity for both sides. Maybe it's positive on one, negative on the other. Maybe it's negative on both sides. So basically that's what this whole section says. So again, the limit does not exist. If the limit equals infinity, it does not exist. It's just describing what's happening. So if we look at this graph here, we can talk about what's happening. I don't know what happened to my pen. Oh, here it is. Okay. Sorry, guys. I can talk about what's happening at these values. Whew. Okay. Here's my. Hold on, y'all. My tools aren't pulling up for some reason. Here they are. Okay. Sorry, I have these annotation tools on Zoom to use. So -1, but from the left, we're on A. So here's -1, here's the left of -1, it's going down to negative infinity. 3 from the right, from the left, that's negative. So 3 is over here, and we're going to be on the left side of 3, so this side is going down to negative infinity. B, -1 from the right. Negative from the right is going up to positive infinity. -1, we have to say does not exist here because these are different infinities. So 3 from the left, negative infinity, 3 from the right is also negative infinity. So we can say negative infinity here. Again, it's just a slightly more descriptive answer, but technically the limit does not exist. So let's scroll down. So I have 8. 8, you can look on both sides. What's happening on 8? We're going up or down? I'm going up on both sides from 8, so I can say positive infinity, positive infinity, positive infinity. You don't have to write the positive. I'm just doing that for extra clarification. You can just write infinity and then negative infinity. Use the tables. Okay, so what are you going to do when you have a table? This is like our first lecture. You're going to put this in Y1. When you do that, make sure you do x plus 6 divided by quantity x minus 2. Very important. So let me pull up the calculator. Hold on, where is it? Here. It's x plus 2 over x. X plus 6 over x minus 2. All right, so I'm gonna clear that out. So x plus 2, no, plus 6. Keep forgetting x plus 6 over x minus 2. X plus 6 divided by x minus 2. Make sure your second table set in the window. It's on ask already. So I go to the table and I'm going to type in these things. So I'm going to type in 1.9. Enter. 1.99. Enter. 1.999. Okay. So what's happening is it's getting to be very, very large, but very large negatively. Okay, so that means that it's approaching negative infinity. So these were all large negative numbers. Oh wait, you can't see. I have to, hold on, let me share my other screen. So I don't remember these exact values, but it was like -79, -7999, -79999. So these were very large, getting very large negative. So this is going towards negative infinity. But what's happening over here? So let's see. Now we're gonna stop my sharing here. We're gonna plug in 2.001. So let me share the calculator again. And now we're going to plug in 2.0001 to 0.001. Okay, so you can automatically see these are large, but they're large positive numbers. So that means that overall, I have to say the limit does not exist because you're getting, hold on. My share stopped for some reason. Let me go. Hopefully you saw that. So we're going to have to say that the limit doesn't exist because these were large positive numbers on this side. This was like 8,000 something. Okay. So, and this was negative 79999. So this is negative and this is positive. This is going towards negative infinity. This is going towards positive infinity. So we're going to have to say that this limit doesn't exist. This is one way to figure out what's happening. Just remember that you have to do both sides to see if you're going in the same direction. Determine if the function approaches negative infinity with this guy. Okay, so I'm going to break it up and I'm going to look at the left side and the right side, what we call analytically, by plugging in numbers. So let's look at the left and let's look at the right. And all you need to do is remember that you're going to, the answer is infinity in this case, okay? But you're trying to figure out the sign. Is it positive or negative? Because if I plug in 4, I get a number over 0, which means that it's an asymptote if you have a number over 0. If it's 0 over 0, that's a whole, and that's something you need to factor out to remove. But if it's in O, then it's an asymptote. So I just have to figure out the sign. So basically, if I plug in something smaller than 4, like 3.9 minus 4, this is going to be a negative number because the 4 is the negative part and it's bigger than 3.9. But then you're squaring the negative number. So basically, this is always positive because it's squared. And this is always negative on top because it's a negative 1. So my overall sign is negative. And this is going to be the same case over here. I don't even have to worry about it because I see that this is a squared. So this is always positive. This happens to always be negative. So the answer is going to be negative infinity. So if I want to say what's the limit as x goes to 4 of negative 1 over x minus 4 quantity squared, I could say negative infinity, or I could say does not exist. So that's an example there. This is just saying if you have a vertical asymptote, you're approaching infinity in some way, maybe just from one side, maybe from both sides, but you're approaching infinity, either positive or negative. And this is saying if you have a number on top of 0, you got an asymptote. That's what all of that means. If you have a number on top of 0, it's an asymptote. So let me see, because the whole 0 over 0 is a whole, but the number over 0 is an asymptote. I need to factor the bottom. I always recommend factoring if possible because you can see if you can remove stuff. In this case, I can't cancel anything out, which means both of these guys are non-removable. This would be 0 when x is 1, and this would be at x equals negative 1. And so what I'm doing right there is I'm setting these factors equal to 0, and I'm just solving in my head by subtracting over, okay? But these are both vertical asymptotes because you have a number on top and you have 0 on the bottom, either of those places. This one, I need to factor the top and the bottom first because I see I might be able to cancel something out. I have a GCF of x, so I had x minus 2. This one is a difference of squares, which we've seen a lot, and so hopefully you know by now it's x minus the square root times x plus the square root of whatever the number is here. And then I see these remove, so that is a whole, not an asymptote. At whatever makes this 0, which is x equals 2. But this one left over, that's the vertical asymptote, and that is at x equals negative 2. Example 6, okay, natural log, you just kind of have to know that function. The natural log of x, I do have a little video that quickly goes over that. Natural log looks like this normally, this point is 1, 0. This is plus 5, which means it's shifted left because if you remember the inside horizontal goes opposite. So left 5, 1, 2, 3, 4, 5. Okay, so that point is now here, which means its asymptote is one thing over Okay, 1, 2, 3, 4. Its asymptote is at -5. And so that's where the asymptote is. X equals -5. Because normally that's at x equals 0, but it's been shifted. Secant of pi over 2. I'm going to show you the calculator there. So let me pull that up. Because I know those functions are hard to remember. So let's go y equals clear secant is the reciprocal of cosine. So I'm going to do 1 divided by cosine of pi over, where's the pi? I see it. Hold on, y'all. Let me, for some reason, I cannot find my pi on here. Let me look at my calculator. Oh, second arrow. Yeah, there it is. Okay. So it's pi over 2. So this one, pi divided by, whoops. I don't know why it did that. 1 divided by cosine of secant pi divided by 2. Because it said secant of pi. Oh, I need an x. Whoops, x. X. All right. Let's see. I'm going to zoom and I'm going to do zoom trig. And what does it look like? Ah, okay. So it has lots of asymptotes. Lots. Let's see. Where are they? If we trace, so I have the asymptote. I wonder what that value is right there. Trace to, okay, so that's 2 pi. Let's see, trace. Over 2. Sorry guys, I wanted to pull something up real fast. Where did my notes go? Okay, so this is going to be kind of a deep dive into trig. For a minute, I'm going to review something about periods and how you graph secant. This is not, what do I say? This is not super important, but it's still good to know. So I'm going to model it for you. I don't want you to get too concerned if you don't remember this particular example. I need my annotation tools though. Where are they? Come on, tools. Come on, man. Where are they? They don't want to pull up. Okay, there they are. Fine. Okay. So let's talk about what secant is. Secant is the reciprocal of cosine. We already talked about that. So this is like 1 over cosine of pi over 2x. But I'm going to talk about how you graph this even without looking at the graphing calculator. So if you remember, you're going to take 2 pi divided by b to get the new period. B is the number in front of x. So if I take 2 pi and then divide by pi over 2, that's 2 pi times 2 over pi. The pi's cancel, and that means my period is 4. So what that means is that it takes from 0 to 4 for cosine to make one full wave. Cosine starts at its maximum, then it's going to cut to the center, and then it's going to go to its minimum, then it's going to come back to the center, and then back to its maximum. So this is the cosine function. Secant, if you remember, it looks like this. It makes little kind of U-like things, and the zeros then are going to be not existent because the reciprocal of 0 is undefined. And so where do we see our asymptotes? Our asymptotes are at 1, 3, 5, basically at every odd number. Okay, so k plus 1 times n. That's how you do it. Or 2k. Oh goodness, 2k plus 1. My bad. 2k plus 1 times n. That means every odd number, okay, for forever. That's where you have your asymptotes for that one. Again, I wouldn't worry too much about that particular example. Properties of limits, just kind of like properties of continuity, you can add or subtract limits. So if you have one going to infinity and the other one is going to infinity, then it would they would be going to infinity. Let's see. F times G, so if they're both equals infinity, and then it equal negative infinity if one of them is less than 0. And then let's see, it says, all right, so basically what number 3 is saying is if you have a number on top and you have this bottom guy is approaching 0, okay? So it's getting close to 0, either negatively or positively. What's happening is you're going to be blowing up, because I want you to imagine, remember, this is really like a very small fraction. And when you divide any number by a very small fraction, you're actually multiplying by its reciprocal. So this number is going towards infinity. So basically kind of like, oh, I'm sorry. So that's a number over 0 going to infinity. This is saying a number over infinity going to 0. Basically, they're reciprocals of each other. So if you have some number and you have infinity on the bottom, you're divided by a huge number, then that number is getting smaller and smaller and smaller. That's going to 0. If you have a number that's getting close to 0, that's going to infinity. Kind of treat like infinity and 0 opposite of one another. So if a number is going to infinity on the bottom, function is going to infinity on the bottom, the overall answer is 0. We will talk more about that in the next lecture. Hopefully I'll clarify that. Okay, final limit. So 0 from the right. If I plug in 0 from the right side, that's 2 plus 1 over something close to 0, but from the right side of 0, like 0.001 squared. So what's happening here is this is 1 divided by something that's approaching infinity, which we just talked about above. This means that this is going to, oh my goodness. Oh, I'm tired today. It's not approaching 0. It's approaching, infinity is approaching 0. This bottom thing is approaching 0. It's getting very, very small. The denominator is, which means you're actually multiplying by a huge number. So that means that this thing is going to infinity. And so 2 plus something going to infinity, because this is like you have a number over 0, which is going to infinity. So 2 over something going towards infinity is also going to infinity. Or you can always write does not exist. The next one, I have pi over 2. Pi over 2 from the right. Cosine. You can think about cosine as your unit circle. Pi over 2 is here. The cosine is 0 here. If you're coming from the right side, though, you're at positive x values. Okay, so that's going to be from the positive side of 0. So this is a positive 0. And so you know this answer is infinity or negative infinity. So you just need to look at the signs. I have negative or a positive, so that means a negative infinity. All right, plug in 0 from the left. So e to the 0 is just 1. So we have 5, e to the 0, cosecant of 0. Well, cosecant of 0. Cosecant is the reciprocal of sine. So sine looks like this. Right? This is 0. This is pi over 2. This is pi. 3 pi over 2, 2 pi. Okay? And what's happening is the reciprocal is going to make these guys the asymptotes. And these guys look like this. Okay? So we're coming from the left of 0, which is on this side, and that would be going down, down, down to negative infinity. And so I have 5 times negative infinity, which is going to be negative infinity. 4 from the right, excuse me. That's from the right. Can't see it. Natural log of 4 from the right. So 4.001 squared minus 16. That means this is going to be greater than 16 because it's greater than 4. So the overall thing here is going to be something that's greater than 0. So a positive 0 is something that's coming to 0 from the right side. Natural log looks like this. If we're approaching 0 from the right side, we're going down to negative infinity. And that looks like that's the end of our lecture. All right, guys, don't forget there's assignment help. I'm gonna post that video soon. And then there's also the book. You can look through the ebook. There's lots of examples there and even more videos done by the textbook company.